This video shows how to use LU factorizations to solve a matrix equation. So if a square matrix A n by n can be factored into L and U, where L is the lower triangular matrix and U is the upper triangular matrix, then if you want to solve the system of linear equations in terms of matrix equations AX equals B, you can rewrite the matrix equations in terms of L times U times X equals B. And then in order to solve for X, we multiply the inverse matrix of L times U to both sides of the equations, and we can use socks-shoes property to find the inverse of L times U, which is equals the inverse of U times the inverse of L. So then we get the solutions X equals inverse of U times the inverse of L times B. For an example, if A is factored into two matrices, triangular matrices, lower one and the upper one, then use this fact to solve the system AX equals -16, -60, and 50. The solution can be, if you know that A can be factored into L and U, then AX equals B will be just equals L times U times X equals B. And then we can solve for X by taking the inverse of U times the inverse of L times B. So in order to find inverse matrix of any square matrices, if there exists an inverse, you augment that matrix to I, and then you use some row operations to reduce the matrix U to I, and then the result will give you the matrix, the inverse matrix of U on the right side of this augmented matrix. As a result, the inverse matrix of U is this matrix here, and the inverse matrix of L is this matrix here. And then we know that in order to solve for X, we take U inverse times L inverse and times B. Doing this matrix multiplications, you will get the result for X as -555/8 for the first variable, -50 for the second variable, and then -64.5 for the third variable.